Welcome to this wireless at KTH project demonstration of 60 GHz MIMO setup. And so in this case it's we are using commodity software defined radios, USRPs, to generate baseband signals at the transmitter and the receiver. And we're using the so-called basic daughter boards for the USRPs, and then we're connecting them to some boards developed in the project. So here we have two transmitter boards and here we have two receiver boards, and these have the most important component is a Hittite chip that does the up conversion in the transmitter and down conversion in the receiver. And these chips have an inbuilt antenna with about 90-degree opening angle, and now we have one polarized in this direction and one polarized in this direction. But right now we are just transmitting on this board and receiving on this board. So now it's the size of transmission right now. And so the boards are also, the frequency and gain and so on are controlled by using the general purpose input-output pins of these basic daughter boards. And we have developed the software and the hardware, and we are going soon to make all of this documentation open and freely available. Yes, in addition to the RF boards, which do the conversion between 60 GHz and baseband, we also have a clock board. And this clock board distributes the clock, which is used as the input to the PLL of all the boards, so that when we use this clock board, the two receivers are phase synchronized. And we can have an arbitrary number of boards by daisy chaining these clock boards, because the clock boards can take an external, they have a chip on board with a clock, but they can also take an external clock and relay the clock to the next board. So any number of receiver and transmitter branches can actually be connected to this system. Here is the transmission. Here you can see the received signal in the time domain. So we are transmitting a training sequence and then a burst of OFDM symbols. It's an OFDM modulation with 16 sub-carriers plus one sub-carrier for phase tracking. And we do this with 25 megasamples per second. And this is the constellation at the receiver. And so this is, if you look at the SNR here, it's like 10 dBs or so, but if you look at the SNR here, it's higher, and the reason is that the signal itself is not entirely clean, which is quite typical for these high carrier frequency systems. And we can also show that this is works quite well. We can move the receiver board away like this, and thanks to the reflections in this room we can also point it in some different directions. So now they are actually pointing towards the wall. There the signal disappeared, now it's back, so you can see it's working. But we have these properties of this high carrier frequency, and the output power is also not extremely high, which is also quite typical at these frequencies. Now, as you can see here, the USRP boards are connected by the so-called MIMO cable, and the MIMO cable synchronizes the time and the timing of the AD converters of the two boards, so we can actually do MIMO. And so let's do MIMO. So there's now an MMSE receiver operating, and we have some training sequences also to estimate the MIMO channel. And here we see the constellation of the two streams. And at the moment you are watching a transmission where we have one transmitter antenna is transmitting on a vertical polarization, and one is transmitting on a horizontal polarization, and the same thing at the receiver. But we can try to change the polarization at the receiver and see what happens. And come on. And as you can see, it's getting worse, but it's still working. It's still possible for the receiver to decode the data, even though there's a linear receiver first separating the two streams. So we will make the design and software hardware available openly, and we are also going to publish some measurements from this that can be used to test phase noise compensation schemes and other dirty RF aspects. So for instance, this MIMO setup was done without any pre-coding at the transmitter, so just transmitting two streams on the two antennas, and probably this can be improved maybe with power control and other phase adjustments maybe between the two transmitters. So thank you for your attention.